Yeah, absolutely. Thanks for having me. Hey folks, my name is Pratyush. I've been with Capital One for about 9+ years now. Over the decade, I have had my hands on a wide range of projects, but a huge part of my focus outside my day-to-day has been in the open source community as a maintainer and contributor to Cloud Custodian. I've spent a lot of time thinking about how we govern the cloud at scale without slowing down the engineers who are using it, right? So now, in my time in the industry, especially working with the broader cloud custodian community, I have had a front row seat to the standard rule book for cloud governance, how cloud governance rule books are being evolved, right? We have our playbooks for tagging, for right sizing, budget controls, etc. But as these AI workloads start hitting various environments, I'm seeking them break some of our old assumptions and utilizations and spend. So here is the thing. AI didn't come with its own set of rules. It just piled on top of the ones we already had, but it's stretching those rules to the breaking point. It's like trying to use a standard car manual to maintain a jet engine. The basic principle of fuel and exhaust are still the same, but the stakes, the speed, the cost of an error are on a completely different level. Because of that speed, we are starting to see new types of waste, old dashboards not being relevant anymore. So I'm going to talk about things today. We'll dig into things like zombie GPUs, where your bill says the hardware is busy, but your model isn't actually learning anything. And API leaks, that's the second thing we'll look into, where a model is left running and billing even when the room is kind of empty, like it's not being used. So let's jump right in. Fun fact about me, I think the most fun fact about me is that now I'm a dad to twins and they recently turned one. I think this has been the most enjoyable phase of my life. Cool, let's jump right in. All right. So first off, I want to give everyone in this room some credit. You aren't starting from scratch here. If you are in FinOps, you already have the fundamentals down. You know tagging, you know budget control, you definitely know right sizing. But we are hitting a classic all that glitters is not gold situation with AI. It's the gap between utilization, is the engine running, and efficiency, is the car actually moving towards their destination. Think about what happens with GPUs. On a standard monitor, you might see a card at 99% load. To a traditional manager, that looks like a great ROI. But busy hardware doesn't always mean useful work. We are seeing what I call the zombie GPU. It happens for a few reasons. Maybe there's a bug where a data loader is spinning its wheels, waiting for the file that doesn't exist, or the model has essentially died. It isn't learning anything new. But the GPU keeps crunching numbers anyway. You see deadlocks where one card is just sitting there at high power, waiting for a signal from another card that's already crashed. Same thing, it's busy doing absolutely nothing. Then there is the other side of the coin, which I call model tiering. It's really about avoiding a massive spec to task mismatch. It's like using a supercomputer to run a basic spreadsheet. You're paying for world-class reasoning power when the task only requires basic text processing. So the intelligence landscape today is tiered. On one hand, you have the PhDs, the high tier models like Claude or Gemini. They're massive, they're brilliant at complex reasoning, but they're slow and expensive. On the other hand, you have the light or mini version. They're lightning fast and they cost next to nothing as compared to the other models. The blind spot here is simple. If a team is using a PhD model just to summarize a paragraph or extract some text, you are burning money. Our job now is to implement model routing, make sure we are using the cheapest model that actually gets the job done. So we aren't throwing away our playbook. We are just acknowledging that the game has changed. Moving forward, we have to start asking sharper questions. We can't just ask, is the server on anymore? We have to ask, what job is it actually running? How efficiently is it running the GPU? And is this actually the right model tier for the task? So now that we know what to look for, the zombie GPU and the supercomputer to spreadsheet mismatch, let's talk about the two ways these workloads actually show up in your environment. I call them the two beasts. Even though they both hit your cloud bill, they behave in a completely different way. On the left side is the foundation model. Think of this as consumable AI. This is your Gemini or your GPT-4 or your Claude. You don't see the hardware, the cooling fans, or the chips. You access these through the API. Now you might ask, if I don't own the hardware, how does it live in my cloud? So think of it like a virtual lease. The model stays in the provider's data center, but the faucet, the API endpoint, is plumbed directly into your VPC. You control the faucet and you get billed for every drop of intelligence that flows through it based on tokens, request volumes, and whatnot. On the right side, we have the second beast, which is what I call custom model. This is infrastructure AI. This is when you are hosting the model yourself. Maybe you are fine tuning an open source model or building something from scratch. Here, the beast is fully visible. You see the cluster, the GPU instances, and the massive storage buckets. You aren't just paying by the token, you are paying by the GPUR, the storage volume, and for those idle endpoints that stay active even when no one is using them. This is where the zombie GPU lives. The risk here is sprawl, forgotten experiment, and orphaned resources that quietly drain your budget. But here is the one foundation part at the bottom of the slide. The governance instincts are identical, whether it's an API or a cluster. You still need tagging, so that you know who owns the spend. You still need lifecycle rules to clean up the mess, and you still need to right size so you aren't overpaying for capability you don't need. So let's look at the infrastructure piece, those custom models we just talked about. This is where things get messy. With custom models, you have full visibility into infrastructure, but that visibility can be a double-edged sword because resources are often short-lived and there's high churn. Sprawl accumulate when resources are short-lived, sprawl accumulates faster than almost anyone can track. I want to walk through a specific pattern of ways that I see consistently. Training jobs that never stop, as Sunny mentioned, SageMaker jobs that may be running for 48 hours or so. This is the zombie GPU in action. You have jobs running for hours or even days with absolutely no checkpoint progress, no timeout enforced, and no owner watching the dashboard. Second is the endpoint sprawl. Think about your dev, testing, and staging environments. Teams spin up these endpoints for a specific experiment. The experiment ends and the traffic drops to zero, but the billing keeps right on going. Nobody ever goes back to retire them. So they sit there on your bill like a ghost. Third, and this one is the most silent killer of the budgets, checkpoint and artifact sprawl. Every time you run a training job, it spits out logs, intermediate files, and any massive checkpoints. These aren't small files. They are like multi-gigabit monsters. If you don't have lifecycle rules to sweep them away, they pile up in your storage buckets forever. And finally, tuning jobs fan out. When a data scientist runs hyperparameter tuning, they might launch dozens of parallel workers at once. If those workers are over-provisioned or duplicated across different experiments, you aren't just wasting a little bit of money, you are multiplying your waste. Here is the hard manual processes are where AI budgets go to die. If you're still relying on spreadsheets, monthly cost reports, or friendly reminders on Slack to manage your cloud spend, you're playing a losing game. At the velocity AI moves, by the time you see the bill, the damage isn't just done, it's probably been compounded 10 times over. So we need to stop thinking of governance as a review and start thinking of it as an automated guardrail. This requires major shift in how we operate. Policy or the guardrail should start at the lab bench level. Most people think governance is for production, but in AI, the massive waste happens during development and exploration. Your policies have to live at the notebook level, not just the deployment level. Stop trusting humans to clean up. Data scientists are paid to innovate, not to manage cloud infrastructure. If you don't automate the life cycle, the idle cleanups, the endpoint retirements, you are essentially choosing to leave the lights on in an empty building. Right sizing, you can't just right size once a quarter. GPU tiers and model capabilities drift every single week. You need a continuous feedback or control loop that ensures you aren't using a high tier PhD model when a flash model would suffice. And finally, like in old days, we would bolt on budgets after the fact. Today, we need to bake in job timeouts and token caps at the provision stage itself. If a job doesn't have a limit, it doesn't start. All right, let's get a little bit tactical now. If everything I've said so far makes sense, your next question is, where do I start? So I've narrowed it down to 4 foundational policies. I don't look at these as optional extras. I see them as baseline. If you want to run a stable AI environment in 2026, these 4 policies are really where you need to start keeping things from spiraling. Automate the off switch. We need to enforce model and compute tier limits, set the limit before the work starts, and finally enforce an approved model list. Going deeper, let's get into the weeds. Those 4 policies we just talked about, they are the universal commandments. But to actually execute them, you have to know which native levers to pull in your specific cloud environment. I want to be clear, the issues we are about to discuss aren't unique to one cloud provider. Endpoint sprawl, runaway training, and shadow spend happen everywhere. But each cloud has specific high precision tools that are perfect for solving these universal headaches. Runaway training jobs, think of this as zombie GPU we talked about. It is the single biggest source of GPU shock in the industry, whether you are on AWS, GCP, or Azure. A single misconfigured training job can burn like through months of budget in like 48 hours. Endpoint sprawl, this is a classic behavioral problem. Teams spins up custom models for an experiment. They get their results and they move on, but they leave the lights on. Ungoverned API adoption, because foundation models are so easy to access via API. Shadow API spend is exploding under the radar. You must enforce an approved model list. For example, on Azure OpenAI, use the gateway to block unapproved model request. If someone tries to use a high-tier PhD model for a task that a Flash model can do, route them to the cost-effective alternative automatically. And moving on to the last slide, what looks good. I want to wrap things up by talking about what success actually looks like in practice. We have covered a lot, from zombie GPUs to automated cloud policies. But at the end of the day, we aren't just trying to cut costs. We are trying to build an operating rhythm that allows our team to innovate without the fear of budget catastrophe. Think of this as a 4-step cycle: onboard with guardrails, develop with policies, deploy with visibility, and continuously optimize. So if you take nothing else away from today, remember this: AI workloads isn't replacing our FinOps playbook. They just made it more critical than ever. Every GPU hour, every training run, and every single API request represents a choice. And our job is to make sure those choices are traceable. And that's all I had. Thank you all for the time.